Okay, this is now the main assembly of our project. We're going to start off with our Vero board. It's 30 along by 35 up. And we have to use a 3.5mm drill to make the break the tracks. So as you can see, we sort of partially drilled certain holes to make sure that the tracks are broken and that no electricity can flow. And coming up now is like a graphical view of where the breaks are. So first of all, we're going to mount our two coils. The bottom one is our 180 turn coil round a 5mm former, and very important, as you can see on this graph here, that the wires go to the inside of the board like so. So we're now soldering our first coil. You don't have to solder all four, only the two terminals where the wires are connected to. And we're now going to mount the coil above it, which is our 40 turn coil. This is 40 turns of 32 gauge wire around a 5mm format. The height is 10mm. When we solder these, as you'll see, we have to make a deliberate solder bridge between the two coils to connect them together, like so. And here's our graphical view again, so you can see exactly where the coils are going to be. And as you can see, we also have to mount a 10 nanofarad capacitor, which we've done here, and we're just going to solder that capacitor in. And of course, at any time you can pause the video just to check with the video, just to see that you've mounted everything in the correct place. So now we're going to mount our 4.7k resistor and our 1SV149 varicap diode. You'll notice that the varicap diode, the flat end is to the left. So you can see where they've been soldered in here. Now we're going to mount our transistor. If you look carefully, you can see that the left two legs are bent up and down a bit. So we're going to mount our 2SC1815, as you can see, flat down, legs pointing away. And here's the points where they're soldered to. Again, pause the video, rewind at any time just to check what's what. And here's a top view of the mounted transistor, and hopefully you'll be able to see where the legs are bent. And now we're going to get our 1k resistor, and as you can see, that's mounted just above our transistor. And we're just going to solder that as such, and you'll know it's in the right place because when you solder it will match up the same places that we're soldering here. And now our 100 picofarad capacitor. As you can see, it's mounted just above that resistor, between the left and right hand side of that break there. Now what we're going to do now is mount two components. As you can see, the legs are twisted together on one side. It's a 1 nanofarad capacitor and a 100 ohm resistor. So basically one end, as you can see, is soldered. The bottom ends go into the board as shown. Important that you note that where the two components are joined, it looks like on the computer generated view that they're going into the hole, but they're not. They actually, as you can see there, they are in midair. Only the bottom two parts of the components are soldered. The top soldered pair just stick up in the middle of the air. As you can see where they got to be soldered. Okay, here's our 10k resistor to be soldered just to the right of the pair of components that we've just soldered. And again, you can see our two components sticking up in the middle of the air, and to the right the resistor. And again, we're going to solder the 10k underneath. Again, pause the video if you want to see where it's soldered to, just to make sure that there aren't any mistakes. And our black wire we're soldering now from just to the right of the 10k to the bottom of the board. You can use any colour you like, but black, red and green are what we're going to be using for simplicity. Black is negative connections, red is positive connections, and green is signal connections. But again, you can use whatever you like, and we'll just solder them. Okay, right, our next component we're going to be soldering in will be a 2N3819. This is an FET, field effect transistor. Notice by this diagram where the connections are. That diagram will help you in the future because we've got a few of those devices to mount. Yeah, you can see on the diagram here where each connection's got to be mounted. So the flat side to the left, and you can see where the source, gate and drain are, and we're going to mount that and solder in place. Okay, now we're going to mount a 100 ohm resistor, as you can see by the diagram there. Again, pause and zoom into the video just to check. And here we are mounting the component. And here's the underneath view, and we're going to solder that resistor in. And now we're going to mount our 1000 microhenry inductor. You can see that sort of green looking coil there at the bottom. It could also be labelled as 1 millihenry. They're both the same. And now just to the right of that we're going to mount a 2.2k resistor. And then we solder our 10k resistor. And solder that in place. And you can see our board layout so far. You can always pause and check with the video layout as well as the computer generated layout. And now we mount our 1 microfarad capacitor. And every time we show the computer layout board, you'll see text of the component we're actually mounting at the time, to save you having to look all around the board to see what it is we're mounting. So you can see it mounted there. And again, make sure they're soldered in the right places. And just next to that we've got a tiny little 1 nanofarad capacitor. The leads are shorter on that one, so that should go in the hole nicely. And just above that we're going to mount a 220k resistor. As you can see, it's sort of bent over, and you can see on the diagram there, 220k resistor, leads folded over, it's mounted vertically like so. And now we're going to mount our 1 nanofarad capacitor. This is another 1 nanofarad capacitor. Like so. And we're going to mount our 2SC1815. The flat end goes to the right hand side, as you can see. Okay, now we're going to mount our variable resistor, or our preset resistor rather. If you have a look at the diagram, you can see that the bottom right hand leg is actually bent a bit so that it skips a hole and goes a little lower down. So this is our 100k preset, and as you can see here, just bending that bottom leg so that it skips a hole. Left hand leg goes straight under the transistor we just mounted, and again you'll see clearly as I turn the board round and also as I solder underneath. You can see there, 2 holes skipped like so. And now we're going to mount our next FET, this is another 2N3819 as you can see on the diagram, and the flat side of the transistor is to the left. Again, make a note of where everything's soldered. Okay, and now we're going to mount our next 2N3819. Again, this is going to be one of these transistors where the legs are going to have to be bent around a little bit. You'll see on the computer generated diagram, the left leg goes up, the middle leg goes down, and the right leg stays where it is. And I'll also demonstrate this on the live action video as well. So as you can see, left up, middle down, right untouched. Okay, and there it is, mounted. And now we're going to mount our 1 nanofarad capacitor. And now we mount our 4.7k resistor, and as you can see this is mounted vertically as well. And we solder that. Now another vertical resistor, this is our 220 ohm. Colour code on that will be red, red, black, black for a 1% device. And we mount that as so. And we're now mounting a 10 nanofarad capacitor just above the resistor that we've just mounted. and this again is a small one. It's I think it's a 2.54mm pitch on that, so it'll be straight in as it were. And now another 4.7k resistor just to the left of the capacitor we mounted, as you can see by the diagram. And now we mount another 220 ohm vertical resistor. This will be mounted just to the left of the 4.7k we've put in there. And again, make sure that where the soldering points are match where we're soldering on our video here as well. And there's a little view of the work so far. Okay, now we're going to mount a 470k resistor on the bottom left hand of the board, as you can see there. Mounted just to the left of the two coils. Okay, now we're going to mount another 2SC1815. Again, as you can see, bottom left hand corner, it's going to be one of these unusual mounts. The top left hand leg doesn't actually go into a hole. It's again just limitations of the software we're using. Only the middle and bottom legs go into holes, as you'll see. The top leg we actually bend upwards because we're going to solder that onto a resistor shortly. So label towards you, middle and bottom legs untouched, and I'm just going to zoom in there and you can see where it's been mounted. So bottom, skip one, then the next one up with the label flat side to the right. So again, bottom track, skip one, middle leg goes to the next track up, and you'll see that as we solder it. Okay, so that's them two tracks there. So what we're now going to do is mount a resistor to the leg that's floating in the air. This is going to be a 2.2k resistor. You can see on the diagram there what we're going to do. So one end of that resistor is going to be soldered straight into the leg that's floating mid-air. The bottom end of that resistor is going to go to the second track up, as you can see here. I'm just putting it in now. So solder that to the second track up. And doing it that way round, that means that the resistor won't be wobbling everywhere. It's going to be soldered in. And so the top end of the resistor, as you can see there, just zoomed in. I'm just going to solder to the top end of that transistor, and then they just stay there soldered. They don't mount to any part of the board at all. Okay, now we're going to mount a 1K resistor just to the right of our 100K preset. Like so. And the next component we're going to be mounting is a 7809 regulator. If you have a look on the diagram, you'll see the legs are different lengths. So the leg on the left hand side needs to be short, the middle one long, and the right hand side one medium. And you can see there on our live video as it were how the legs are done, and just show you again on the diagram. Make sure that the legs are in the right place. And we're just going to solder that regulator in place. Okay, now we're soldering in one of our jumper wires, like so. That goes from the middle pin of the regulator up to, well, you see where it's being soldered. Again. And now a 10 ohm resistor just to the right of our wire that we've just soldered in. Okay, and that's that done. And now we're going to solder a 1 nanofarad capacitor onto a board. As you can see, it's diagonal and it has to jump across the wire on the resistor. Mustn't touch any of the resistor legs. So we put that in like so. And now we're going to solder in a 1 microfarad capacitor just below the 1 nanofarad we've just done. You can see it on the diagram there with the text written next to it. Again, make sure that it doesn't touch the resistor underneath it. And again, you can see that it goes between our broken track there. So that's the idea of the broken tracks, you see, is that they allow us to connect stuff without it all being shorted out. Okay, so that's that done. Okay, next device is going to be a 78L05. This is a 5-volt regulator. As you can see, flat label side to the left. Okay, and there you can see it's done. Right, our next component we're going to be soldering in is a 1 microfarad capacitor. Now then, there's if you have a look carefully at the layout where the 1 microfarad capacitor is, that's where you've got to place it. I'm just going to let you know in advance that all the board layouts we've done afterwards, I forgot to put that 1 microfarad capacitor in. So if it suddenly vanishes, don't worry, it is meant to be in there. Okay, this is where we mount all our pin headers. Again, pause the diagram if you need to. We've got a 5 pin header on the right hand side and some individual pin headers on the left. So we're going to start mounting those. And again, feel free at any time to rewind the video a little bit or pause it. You can see it's soldered there, and we're just going to speed things up a little bit any second because there's still a few more pin headers to do on the left hand side, so we just zoom through them, we won't keep changing between them. As you can see, I'm cutting the individual bits off there. When you buy the pin headers, they come in a long string, normally of 40 pins, so you just cut off what you need with a pair of pliers, easily done. And our first one mounted is one above the bottom on the left hand side, as you can see. And we'll just whiz through the soldering of each pin header. Again, pause the video if you want to double check where everything's soldered. Header number 2. Header number 3. Header number 4. And header number 5. And I'll just leave that there for a second so you can check everything's as it should be. Okay, well that's the analog side done now. You can take a pause at this point, or you can carry on and steam ahead to the digital side. We're over the halfway point now. And we're going to mount an IC holder, as you can see, and there's a little DIMM port at the top. That's useful. You're going to need to mount that correctly. You'll see why shortly. And the pins have got to be just to the right of where those holes are drilled. So immediately to the right of those holes are one set of pins. And of course the left hand side of pins will be 2 holes away from those parts where it's been drilled. And now we're going to solder them, and of course you'll be able to see from how we've soldered where the pins are located. And using the magic of video, I'm just going to magically solder all of them all at once. Now what we need to do now is that bottom right hand pin, we need to make a short circuit to the next track above, because that's going to connect it to the positive line. And now we're going to mount a wire, bottom left hand side of the IC holder. As you can see, there's a short black wire we have to mount. Okay, and now we're going to mount a red positive wire to the right of the chip, as you can see. Okay, and now we're going to mount the first of 8 470 ohm resistors. So you can see our first one there, just to the top right of the chip. And again, make a note of where it's being soldered to make sure it's on the right pin of the chip and the right position of the board. And our second resistor, you can see, is at the bottom right hand side of the chip. Third resistor, just slightly down and right to the second resistor. And our fourth resistor, just to the right of our top resistor. These resistors basically connect the chip to the display. If you were to wire the display directly, there'll be too much current and it'll probably blow the chip, the display, or both. So they're basically just current limiters. And another 470 ohm just to the right. And guess what? Another 470 ohm resistor. And another 470 ohm resistor. Like so, and don't worry, there's only one more after that. Okay, and there's our final 470 ohm resistor. Okay, now we're going to put in our wire links. You can see at the top a green wire link. And just above the IC we're going to put another shorter wire link, as you can see, the green one there. And another green wire link to the left of the IC holder, as you can see. And another green wire to the left of that one. Well, the camera angle's a little bit off there, so you just have to take my word for it. You can see where it's being soldered anyway. You can check the computer generated board layout as well. There we go. And yep, that's it, you guessed it, another green wire, a short one just to the left of the ones we've done. This one just about made it on camera. And there's the soldering being done. And now we're going to mount, what is it we're doing here? I've actually lost track now. I think, is it another wire? Yeah, it's a long wire. Yeah, so as you can see, it's a long wire to the left of the chip. Okay, and here's a view so you can see what's going on. Right, 1 nanofarad capacitor now is what we're going to be mounting. You can see it to the left of the board, right to the left. And you can see where it's being soldered there. And just above that capacitor we've just soldered is, you've guessed it, another wire link. Just about got that one on camera. And another wire link just to the left of the one that we put on, so that's right to the very left of the board. Okay, now we're going to solder a 22 PF capacitor. You can see it there, the orange thing just to the left of the IC. And a second 22 PF capacitor just to the left of the one we just done. You can see it's mounted, top leg is mounted just a little lower. And now we're going to mount a 2SC1815 just to the left of the capacitors we've done, and as you can see the flat label side points to the right. And now we mount a vertical 470k resistor just to the left of the transistor we'll just put in, as you can see. And now a 2.2k resistor just to the left of that resistor we just put in. We're just a couple of components away now from finishing the main circuit board. Right, apologies for the fact the camera's starting to get a little blurry at this point. Hopefully everything should still be visible enough. Right, 16 megahertz crystal is what we mount next. You can see that the right hand leg is just slightly harder than the left hand when we mount it. The crystal we've actually mounted was a smaller crystal diagonally, as you can see. The big crystal was just for the display purposes. This is a 16 megahertz crystal. The holders, right? If you look at the top, there's the holders here for the display, like so, and you'll see them mounted in. As I was going to say, there's two chips that can be used for this. There's an AT Tiny 2313 which runs at 20 megahertz, and then there's an AT90S2313 which is what we're going to be using here. Technically it's only meant to run at 10 megahertz, but most of them we can actually run at 20, but the program that we're going to install has been programmed for 16 meg, which will just guarantee that they're all going to run overclocked, as it were. This will enable us to capture frequencies up to around 10 megahertz. And we solder in the little display holders, as you can see. Right, the next thing we do now, I do believe, is at the capacitor. Yeah, if you look to the left of the board, there's a capacitor which is sort of dangling off a little bit, and I'll show you how to do that. This is actually going to be a very useful thing to know. You'll see why in a minute. So what we do, we're going to tin a bent leg of our capacitor, we're going to tin the red wire, and then we're going to just heat the two together, and they'll just solder like that. And then using some cutters, we're going to gently grip the wire, and we're going to push it. So not so tight that it cuts, but just so it digs into the wire or the insulation. And if you have a look, we're pushing the insulation all the way up to the end of the capacitor so that our solder joint is hidden. Now you can mount it either where we're going to be mounting it here, or the other alternative is actually right on the negative and positive supply of the chip. Basically the idea of that capacitor is just to help stop any noise getting from the chip to the rest of the circuit. I'm just stripping off the bit of wire so that the length is correct. And soldering on the positive rail, and you can see now while we did that solder bridge, it just enables that top leg of the chip to connect to a lot of other components. Okay, and what we're going to do now, on the right hand pin header, we're going to short circuit 2 of the pins, because on final assembly we're going to need 2 negative pins. So we're going to do a deliberate shoulder sort on those 2 pins, as you can see there. One of the pins you can see is a break, so the negative isn't going to short any of the other components around it. Okay, and that's the assembly of the main board, and all we need to do is just plug in a display just to make sure that it works, and if it works we should get some numbers, and the numbers should change as you adjust the coil. During final assembly we'll explain why we've done a few of the slightly more unusual things we did, like our resistors with legs sticking up in the air and stuff. So here's our chip with the little dent at the top side. We're going to carefully plug that in, and then we're going to plug the display in, and one side has got some writing on it. That should be the side that goes on the right hand side. So it's where the decimal points are. It goes to the right hand side, and we just plug it into our sockets. The reason we use sockets is so it makes it easy to have the display on external cables and mount it to a box and everything. And of course the last thing you want to do is have everything manually soldered in. You put it together and it don't work, and you've got to desolder it all and everything, so the plug and socket arrangement makes it very useful. And believe it or not, this actually worked first time. Yep, it doesn't happen very often. And you can see it's reading a frequency, 492, 493 kilohertz. And if you adjust the coil, you can see the frequency changes up and down. That means everything's working beautifully. So basically that means we're now ready for final assembly.